On to functions then. So what are they? How do we write them in maths, and what's the various terminology associated with them? Again, as these videos nearly all are now, it's a higher tier subject. We write a function like this with an f brackets, and technically the letter inside the brackets can be absolutely anything. You can use any word you want to, but we generally use an x. It's just the same as with algebra, where we tend to use an x to represent things, or at least the most commonly used one. But strictly speaking, you could use any letter or word. What this is saying though isn't that there's the value of x in that bracket. Instead, it's saying that there is an input of x. So think of the function, the f and the brackets, as a computer, and into that computer is being put the variable of x, and x is some sort of value. So for instance, if x was 3, we'd be putting that value of 3 into the computer. Now the output could be anything. So the function, this f bracket x bracket, could be equal to x plus 1, for instance. So the function itself, if you like, is a variable, or it's an equation. So whereas x can represent a number, the f bracket x bracket, the function of x, represents an equation or something we're doing to it. So inside the computer, you've got the processor that adds 1 to x and then puts that out. So we can put any value of x into the function because it's saying in the brackets x. The function adds 1 onto it because the function is itself x plus 1, and it gives out the value of x plus 1. So we can say that the function of x is equal to x plus 1. So if I was told the function of x is equal to x plus 1, what is f bracket 3 bracket? The answer would be 4, because 3 plus 1 is 4. Here we've got some examples then. With each one, we're putting in an input of x equals 4, because the function is represented by f bracket x bracket, so we need to be putting a value in. So we're putting the value of 4 into this function, and I've got 3 examples here of what the function could be equal to. So in the first one, the function of x is equal to x minus 2. The second one, the function of x is equal to x plus 1. And the third one, the function of x is equal to 2x. So with all these computers, we're putting an input of 4, but the computer, because the function is a different equation, the computer works out the answer differently. So with the first one, when the 4 is put in, the answer to the function is 2. So the function of x is 2. So x is 4, the function of x is 2. And the reason being is because the function of x is equal to x minus 2, and 4 take away 2 is 2. With the second one, the function of x is equal to 5, because the function of x is equal to x plus 1, and 4 plus 1 is 5. And then the third one, the function of x is equal to 8, because the function of x is equal to 2x, and 4 times 2 is 8. So the function of x represents an equation, and we put in an input of whatever is in the brackets to give an output according to what that equation tells us to do. We can also represent the function through this technique as well. So whereas we could have f bracket x close bracket is equal to x plus 1, We can also represent it by this, and you have to know this notation as well, where we've got f colon x instead of the f bracket x, and this little arrow with a line by here instead of the equals. So this is the same as f bracket x close bracket is equal to x plus 1, but instead we've got f colon x, little special arrow sign, x plus 1. We've got two terms as well in functions. We've got the domain, and those are the values that are put into a function. So I might have a function where I'm putting in all the even numbers under the 10. So the domain would be 2, 4, 6, and 8. And you could represent that as a set. Remember to go back into, if you don't know what I mean by a set, have a look at the video on sets. The range then are the values that come out of the functions. So if you had a function of x plus 1, the domain is even numbers under 10. The range, because we'd be adding 1 to each of the even numbers, would be 3, 5, 7, 9. So, for instance, by here, we've got the function of x is equal to x plus 5. So when x is inputted, the function adds 5 onto the x to give out an output of x plus 5. And we're saying that the input is all the whole odd numbers below 10. So the domain is 1, 3, 5, 7, and 9. Notice how I've represented them as a set. If we did the function of x is equal to 1 over x minus 2, the domain cannot be 2. So sometimes we have to exclude numbers from the domain. There are numbers that it cannot possibly be. Now, why can't it be the 2 in this particular case? Well, the reason being is that if you put in x is 2, then we've got 1 over 2 minus 2, and 2 minus 2 is 0, and you can never divide 1 by 0. It's not possible. So always look in a question to see if there are certain values that cannot possibly be in the domain. So if the question for this one was all the even numbers under 10, we would leave out 2 because the number cannot possibly be 2. So you would do the function with 4, 6, and 8. So that's what a function is, how we work them out, and the various notations and terminologies associated with them.